Continuing lesson 5.1 on estimating solutions by inspection. If you look on page 260 at the key concept, we can look first at slopes and then y-intercepts to figure out how many solutions we have. So this actually is the most common case that we normally would have, I would say, is one solution. If you look at these slopes, this has a slope of 2. This has a slope of 3. So slope of 2, slope of 3, they're going at different angles, and if lines are going at different angles, they're going to intersect each other in one point. So that has one solution. In this next case, the slopes are the same, the y-intercepts are different. So they're going at the same angle as each other, but they have different y-intercepts. That means those are going to be parallel lines. And parallel lines never intersect means we have no solution. And then finally, not too much of a trick there, they just switched the terms around. Both of those equations are y equals 3x plus 4. They have the same slope, they have the same y-intercept. The lines are the same as each other basically. And that means we have infinitely many solutions. Those lines are always going to be intersecting each other. So look at the do you know how number 4. Kyle has X 3-ounce blue marbles and a 5-ounce green marble, assuming that means 1 then. Laura has X 5-ounce green marbles and a 3-ounce blue marble. Is it possible for them to have the same number of green marbles and the same total bag weight Y? So could they have the same number of green marbles? Okay, so the total bag weight is Y. So we're going to look for what their equations are first. So we're going to have the weight equals something. So for X 3-ounce blue marbles, that would be 3 ounces times X for the blue marbles, and then he has 1 5-ounce green marble. So Y equals 3x plus 5 would be his equation. For Laura, the total weight. So for Laura's, we've got X 5-ounce green marbles, so that'd be 5x, and then 1 3-ounce blue marble, that would be plus 3. So Kyle's Y equals 3x plus 5, Laura's is Y equals 5x plus 3. And the question is it possible for them to have the same number of green marbles and the same total bag weight? So basically what we're thinking about is if these would intersect each other, then we should have a solution here. So since the slopes are different here, that tells us we are going to have one solution. If we have one solution, then it should mean that this would work. Now, what's a little confusing on this problem is for Kyle, X is representing the number of blue marbles, and for Laura, X is representing the number of green marbles. So it's a little bit dicey here to just say that by just what the fact that these have one solution. If you worked this out, again, we're not to the point of doing this yet, but if you worked this out, these lines would intersect at the point 1, 8, which means X is 1 and Y is 8. So what that would mean for Kyle would be one blue marble, right? One blue marble, and we already knew he had 1 green marble. For Laura, x was the green, so that would be 1 green, and we already knew he had 1 blue. So it ends up, basically they both have 1 of each marble. This question is probably not the best one for us to take the equations and interpret by saying that we have 1 solution and that they can have the same amount of marbles, because they use different, they use the same variable for different colors of marbles, okay? If you look at number 5, how many solutions does this system of linear equations have, and explain? The first equation, it's kind of switched around, but if these are equal, we just switch the sides and they're still equal. Y equals 1/2 x. Then at that point, both of the equations are y equals something. So we should be able to tell what our slopes are, what our y-intercepts are, and then we can tell how many solutions we have. So the slope of the first line is 1/2, so slope of the second line is 1/2. So the slopes are the same, means we're either going to have parallel lines or the lines are going to be the same. The only way for the lines to be the same is if their equations are identical, which sometimes you can't tell unless you solve them for y, but these you can say are not the same. That first equation you could put plus 0 if you want. It would have a y-intercept of 0. The other one has a y-intercept of 3. So just to kind of sketch out a little bit of what this might look like, would be maybe something like this. Would be the first equation, and then the second equation would be something like this. Okay, so same slope but different y-intercepts. These are parallel lines, which means they have no solutions. So we could say no solutions. The lines are parallel. Something to that effect. Number 6, same idea. How many solutions does this system of linear equations have, and explain? So one thing we've been talking about is we've been taking our equations and we've been solving them for y. We've been getting a y equals something. So that's one approach we can take. Maybe that's what we'll start with. Just maybe is easier to be consistently doing problems the same way. And then we'll talk about, after that, I'll just mention some other options we could have done potentially besides just solving for y. So in our first equation, if we're going to try to solve this for y, first thing is we're trying to get the y term by itself. We can't do this in one step, but we're going to try and get that 3y by itself. So to do that, you can see they're adding 6x on that side. So we're going to do the opposite operation. We're going to subtract 6x on both sides. When you go to do that, I'm going to just squeeze that in front on the right side of the equation. Those are not like terms, so don't try and combine those together. But I'm going to say negative 6x plus 12 because it just makes it easier for us probably to see what our slope and our y-intercept are if we have the x term and then the constant. So we got one more step at this point. We're trying to get just the y by itself. They're multiplying by 3, so we can divide by 3. When you divide by 3, all the terms have to be divided by 3. So if we're taking a third of stuff on one side of the equation, we have to take a third of everything on the other side to keep these equal to each other, keep our equation balanced. Okay, so when you do that, you should get y equals negative 2x plus 4. Second equation, we're going to do something similar. Again, first we're trying to get that y term by itself. They've got an 8x. It's a positive 8x. So we can subtract 8x on both sides of the equation. And again, I'm going to squeeze that in front of the 16. So at this point, we have 4y. To get y, we have to divide everything by 4. And that would be y equals negative 2x plus 4. So at this point, you might notice that those equations are identical to each other. And what that means is we have infinitely many solutions. We have infinitely many solutions because the lines are the same. And just to mention on this problem, there are other ways we could do this potentially. Well, for one thing is they have the x and y's in a different order. So what I would probably do on that first equation is just get it in the same order with the x and then the y. And then one thing you could do then is looking at both the equations, we could try to get one of these coefficients the same, either the number in front of the x or the number in front of the y. And it kind of works like getting a common denominator. So like if you look at the numbers in front of the y, we've got a 3 and a 4. So if you imagine 3 and 4 were your denominators, we could get a common denominator of 12, right? It's a common denominator of 12. I'm not really getting a common denominator, but that's it's the same thought process on how to come up with the number. So to get from 3y to 12y, we'd have to multiply that by 4. So we could multiply that equation by 4 on both sides. The other equation to get to 12y, we can multiply both of those by 3. And if we do that, we're going to have 24x plus 12y equals 48. And then this one will have 24x plus 12y equals 48. I didn't really know for sure that those were going to come out the same, but I knew by how I was doing that, I knew I was going to get a 12y on both of them. So I knew that part was going to be the same. If all the other parts happen to be the same as well, then I know that those lines are the same. This is a little bit of a gamble because if they don't come out that they're exactly the same, then we probably still would have to solve for y, figure out if our slopes are the same and stuff like that. And then another option, since the x's and y's are on the same side, you could find the intercepts. So like if you put a 0 in place of x in the first equation, you're basically left with 3y equals 12. So that would be 0, 4. And then if you put a 0 in place of y, basically you'd be left with 6x equals 12. So if you solve that, x equals 2. So this is finding the y-intercepts of that graph. We could do the same thing on the second equation. If you put a 0 in for x, you're going to have 4y equals 16, which means y equals 4. If you put a 0 in for y, you're going to have 8x equals 16. So x equals 2. And then what you could do at that point is graph those. Well, you might notice the points are exactly the same, which means that they are going to be the same graph as each other. If there's more than one point that's the same, the lines are going to have to be the same as each other, okay? Because if the slopes are different, they're only going to have one intersection point. If they have more than one intersection point, all the points are going to be the same for these straight lines. We'll look at some problems in your workbook. So workbook page 61, we're going to be looking at these first 3 questions. So starting with number 1, what conclusion can you make about this system of equations? The first thing they're asking about how the slopes compare to each other. Neither one of these equations is solved for y. So I'm going to bring these off to the side for a minute so we can solve them for y and then figure out what their slopes are. So on this first equation, we have a 6y, so 6 times y. So to get that as just a y equals something, they're multiplying by 6. We can divide everything by 6. So that would be y equals 2x plus 6. On the second equation, similar idea, they're multiplying by 15. So we can divide everything by 15. And if we do that, it's going to be y equals 3x plus 4. So this is a little nicer format for us to look at, that we can better tell what the slopes and the y-intercepts are on these graphs. So if we look at the boxes in our book here, the first one says the slope of the first equation is blank the slope of the second equation. So slope of the first equation is 2, slope of the second equation is 3. Basically what we're trying to find is whether the slopes are the same or different. So slope is 2, slope is 3. Those are different slopes. So the book has it as the slope of the first equation is not equal to the slope of the second equation. Other than that, otherwise you could put different than. Okay, either not equal to or different than. Technically, at that point, we could go right to our answer. If the slopes are different, we actually automatically know how many solutions we have. So if the slopes are different, we know the lines are going at different angles than each other. And then it's going to make them intersect in one point. So we have one solution. We'll go ahead and fill in this other part just because the book has it there. But if you didn't have blanks, I wouldn't even worry about the y-intercept. We already know slopes are different. We have one solution. We're done. So just because they have it here, we will look at the y-intercepts. Like I said, y-intercept of the first equation is 6. Y-intercept of the second equation is 4. And so these are not equal. Y-intercept of the first equation is not equal to the y-intercept of the second equation. But like I said, normally our thought process is going to be the slopes are not equal, we have one solution, and we're done with that problem. So look at number 2. They're asking how many solutions this system has. The first equation is already y equals, so I like that. The second equation is not quite there, so we're going to get it as a y equals equation. Then we'll be able to tell what our slope and y-intercept are. So to get the y by itself here, they're multiplying by 4. We need to divide by 4. We need to divide all the terms by 4 then. So that would be y equals 3x plus 16. So look at the equations. We got y equals 3x plus 14. We got y equals 3x plus 16. We're figuring out how many solutions we have. So first thing is we'll compare the slopes. So the slope on the first line is 3. The slope on the second line is 3. So the slopes are the same. If the slopes are the same, the lines are angling the same way. Either these are going to be parallel to each other or they're going to be the exact same line. So the y-intercept of the first equation is 14. Y-intercept of the second equation is 16. So kind of give you a visual of this idea of what this kind of looks like. Imagine those are the same slope as each other, different y-intercepts. These are going to be parallel lines, which means we have no solution. So we could say we have no solution, and we could say the lines are parallel. The question technically just says how many solutions are there. So if you say no solution, that technically answers the question. But just want to make sure everybody understands also the reasoning behind that in case they said explain. So look at number 3. Same idea, how many solutions does this system have? I'm just going to rewrite these. Neither of these are just a y equals, so we're going to try to get it there. So for that first equation, we can subtract x on both sides. If you want to put a 1 in front of the x, you can. Doesn't hurt anything, and actually might be of benefit to us later, I guess, to do that. Then if we divide by 3 on both sides, at that point, technically, you can just slide the x off to the side. It's in the numerator, but you're allowed to slide it over to the side. Then on the second equation, they're multiplying by 9. We just divide by 9. When you do that, we've got negative 3/9 x. You might notice that can be reduced, and that reduces to negative 1/3. So we've got y equals negative 1/3 x and y equals negative 1/3 x. So these lines are the same, which means we have infinitely many solutions. They are always going to be intersecting each other at any point. Look at number 4. Ben says this system of equations has one solution. Is he correct? And explain. So like we've been doing, we'll first look at the slopes and then we'll go from there. So the slope of both lines is 1/4. They have different y-intercepts. You can add the opposite there if you want. Same slope, but different y-intercepts. Wouldn't be that steep. Means these lines are going to be parallel, which means we have no solution. So he said that they have one solution, so he's not correct. There is actually no solution. So look at number 6. Again, the question, how many solutions does this system have? So the first equation has a slope of 4. Second equation has a slope of negative 4. So if the slopes are different than each other, we are going to have one solution. We'll look at number 11. They want us to choose a statement that correctly describes the number of solutions there are for this system of equations. So if we look at this, look at our slopes first. Slopes are the same. Y-intercepts are different. And so that means we have no solution. Okay, slopes are the same, y-intercepts are different. Those are going to be parallel lines. Parallel lines, so no solution. So this gives you an idea of how to estimate solutions by inspection. Have a good day.